In this video, I'll talk about the reduction of nitrile group using LiAlH4, which we know it's a strong reducing agent. And we convert that into an amine. So that's one of the great ways of making an amine using a nitrile group when we are reducing this with LiAlH4. And then you're just going to be working it up with water. You don't really need an acid here to work it up. And obviously, when I'm looking at the mechanism, we know the nitrile group is going to be polar, where you have carbon with a partial positive, nitrogen with a partial negative. So what I'm getting here is LiLH4, which got a negative charge on the on the aluminum, and Li plus kind of right next to it. I'm going to go ahead and get this attack. So use that hydride from the LiLH4, attack this, and then this eventually kind of gets a negative charge on that nitrogen, but this aluminum kind of sticks around, so it doesn't really go away. So as a result, it makes it an acid-base complex, or at least acid-base complex if you want to be more correct on that. So nitrogen, it already had an alone pair, so the other lone pair is kind of is used there to kind of hang on to the aluminum there. So I got this complex kind of made here with a negative charge on the aluminum. Li plus is still hanging out there, and now at least I have one hydrogen installed on that carbon. But this doesn't really kind of end there. I can use a hydride again from that, kind of do the attack on here, and then this comes out and works out fine, just because you have a pi bond to break here. So then I get a carbon. Now I've got the nitrogen only with one nitrogen with two lone pairs now, and I get two hydrogens installed on that carbon already. And then I still have that aluminum, so Al3, so that loses the charge because now you only have two hydrogens left on that aluminum. And then just to kind of make sure you get a negative charge to kind of compensate for that negative charge, the lithium plus is going to be hanging out in here. So once you kind of in that particular form, it kind of gets stuck there. And then at some point, we can go ahead and protonate it using water. So you don't really need an acid to protonate this, because this is fairly basic enough. And the amine itself is fairly basic enough that can be protonated by water. So you're going to be using it twice, acid-base reaction. So use the water a couple of times to protonate the nitrogen twice in there. I'm not going to draw the mechanism here, but eventually when you go ahead and protonate it twice, you would have NH2 in there. Now if you were using an acid instead of just the plain water, then I would have protonated this nitrogen again, because remember the amines are fairly basic, so that would get protonated again. I would have an NH3 plus. So that's why I don't want to use an acid in this particular case. So that's how you make the nitriles. That's how you reduce the nitriles with LiLH4 that eventually goes ahead and convert it to an amine. The other reducing agents that you have is the NABH4. That was not a strong reducing agent, so that will not work with the nitriles. It's only the LiLH4 that can actually do the job and reduce this to an amine function group in this particular case. So that's really a great way of making an amine if someone think about it. Like suppose if I have an alkyl halide to begin with, I can go ahead and run. In the first step, I can go ahead and use something like NaCN with pseudonitrile as my solvent. And the second step, I can use LiLH4, and I got to make sure I work it up with water. So in the first step, what I'm really doing is I'm using the CN minus here. That's in a strong nucleophile weak base. And I'm going to go ahead and run an SN2 mechanism here, and I'll have a nitrile group installed. So first I make the nitrile, and then once the nitrile is made, I can go ahead and reduce this using LiAlH4. And then work it up with water. So when I do so, I end up making an amine. The only downside is if I'm starting out with 2 carbons here in the starting materials, when you use an NaCN or Cn minus to kind of run an SN2 reaction, you would have one extra carbon. So it could be a bad thing or a good thing. Like if you don't want to add in a carbon, then obviously you don't want to be using the NaCN in here to do an SN2. But if you're actually looking for extending in a carbon chain, then you can certainly go ahead, add in a nitrile group or the Cn minus or cyanide group itself to go ahead and run an SN2 that increase the carbon chain by 1, and then you can eventually go ahead and reduce it to make it an amine. You can also do other things like the nitriles. Eventually you would learn that nitriles, if I go ahead and hydrolyze the nitrile, I can go ahead and convert this to a carboxylic acid, because the nitriles are also kind of considered the derivatives of carboxylic acid. So I can go ahead and convert it to a carboxylic acid in here within a thing that I got an extra carbon in there. But that's not really the only way you can kind of convert it to an acid. The other way to convert this to an acid would have been, well, if I'm using an ethyl bromide, I can just go ahead and create an ingredient out of that. So if I create an ingredient out of that with magnesium ether, so in the first step, I'll have the Grignard reagent kind of made. And I can just go ahead and use a carbon dioxide in the second step. So use carbon dioxide in the second step, and that would actually add 1 carbon in there. So that, use a different color here. So that would actually do a nucleophilic attack from that carbon onto that carbon of the carbon dioxide. And I make a new bond here and an O minus. And then I can go ahead and protonate this. I can use the third step just using the acid. And once I do that, I'll have this carboxylic acid made again. So that's not really the only way. You can do a lot of these synthesis steps different ways, but you just got to make sure you're not kind of doing something really crazy that doesn't make sense in terms of organic. But as long as you're doing with the nucleophile and with the way that it's supposed to work, it should be fine.